Hello everyone, this is Shivani Agrawal. I am the faculty of the Department of Information Technology in Ajay Kumar Garg Engineering College, Ghaziabad. So, today I start the lecture on the topic of common bus system by using decoder. So, before start this topic, first I explain what is decoder. Basically, what is decoder? Then decoder is n number of inputs and 2 to the power n number of outputs. In this example, we have to define that there are 2 number of inputs, that is A and B, and there are 4 number of outputs because we have take the value of n is 2. So when the value of n is 2, so this is what n is 2 to the power n. So it is 2 is to 4. So there are 2 number of inputs and 4 number of outputs in the working of the decoder. This is the basic working of the decoder, right? Now, what is enable? Enable is just like lock. When we have the lock in the gate, then we can't enter in the gate or in the room. So when the value of A is 0, then the value of A or B is either 0 or 1. So there is no output is produced. But when the enable is high, so if the value of A or B either 0 or 1, so it produces the output correspond to this input value. So always the value of E is always 1. So when we have the 2 number of inputs, so maximum number of combinations are 4. This is 0 0 0 1 1 0 and 1 1. So it is 0 0 0 1 1 0 1 1. This is in binary. When it is in decimal, so it is basically this is the conversion of 0. This is 1. This is 2. This is 3. Right? So when the input is 0 0, then y0 is high. When the input is 0 1, so y1 is high. When the input is 1 0, so y2 is high. When the input is 1 1, so y3 is high. This is the basic working or the mathematical model of the decoder. When we have the number of inputs are 2, so it produces the 4 number of output. Same processing if we have 3 number of inputs, so we have 8 number of outputs, it produces the 8 number of outputs. When we have 4 number of inputs, so it produces the 16 distinct outputs. So this is the basic working of the decoder. Now move on to the previous slide. What is common bus system? Common bus system is what? Convo system means why we use a convo system. Basically, convo system means we use or we construct a configuration of the buses when we construct the bus architecture or when we transfer the information from the one place to the another place. So we use the number of buses for transferring the data from the one place to the another place. So in the conventional computing, in the conventional systems, when we transfer the data, so we use a single bit, we use a wire for a single bit. So when we transfer the data from the one place to the another place, so we use the distinct buses are used for transferring the bit from one place to the another place. So in the common bus system, we design or we construct a common architecture or we construct a number of buses for transferring the data, and we use this particular architecture for transferring the data from the one place to the another place without any reconstructions or without any define the number of wires, or we have to reduce the complexity of the circuit diagram of this particular system. So common bus system is used for transferring the data from one place to another place with the minimum number of complexity, with the minimum desired number of wires. So the complexity of the diagram is reduced. So there are two basically methods common bus system by using the decoder or the mux. So in my previous video, I already explained the common bus system by using the multiplexer, but in this video, I explained the common bus system by using the decoder. So already I explained in the previous slide, that is what is the working of the decoder. Now in this particular slide, I explained what is tri-state gates, because we used the construction of the common bus system by using decoder and the tri-state gate. So what is the basic working of the tri-state gate instead of multiplexer? So tri-state gate means we have three type of states. First state is the normal input state. Second is this is the control input state. This is the control input state. And third is the output state. So when we have the control input, so if the control input is 0, this is same like as log. If the control input is 0, so there is no current is flow in this particular gate. This reacts as an open gate. This reacts as a open gate. Okay. So when the control is 0, when the control is high, so when input is 0, the output receives 0. When the input is 1, so the output is 1. But when the control is 0, so if the input is 0 or 1, it is x, basically x is either 0 or 1 because there is single input. So single input, the number of possibilities are 0 or 1. If there are possibility either 0 or 1, so the output receives as Z. Z means high impedance. High impedance. That means no output has been produced, or the circuit reacts the output as a high impedance output. So this is the output is the high impedance. If the control is 0, if the control is 0 or the control is low, so the output receives as a high impedance. So this is react as a open circuit. So this is the basic working of the tri-state gate. Now move on of the next slide. Okay. So how we have the use of decoder with the tri-state gate for the working of the construction of the common bus system. Basically, the same question I repeat in this particular slide. If we have the 4 registers and each register has 4 bits. If we have 4 registers and each register has 4 bits, so what is the size of decoder? Basically, the size of decoder is totally depends on the number of registers. So how many registers we have? We have 4 registers. So the size of decoder is it is 4. So it is basically 4 2:4. And how many decoders are used? This is depend on the number of bits. This is bits, 4 bits. So there are 4 bits are used for the designing of the decoder. Okay. So how we have to implement or we have to design this particular common bus system by using decoder. So in this the working of decoder is n is 2 to the power n. So there is 2 to the power 4. 2 is the input size, 4 is the output size, and we have the 4 number of outputs. So it is 0, 1, 2, 3. There are the input conditions are I0 and I1. So if it is 0, 0, then this input is high, rest inputs are low. This is the tri-state gate. So it is basically A0, B0, C0, D0. Corresponding, we have 4 decoders. So it is decoder 1, decoder, suppose this is D0, same as D1, same as D2, same as D3. This is the basic construction. So this is basically the basic architecture that I defined in this particular slide. So there are the 4 number of 4 tri-state gates for the 4 inputs, because we have each register has 4 bits. So there are 4 bits. So it is the each register bit, take the first bit of each register. So it is A0, B0, C0, D0 if it is decoder 0. Okay. And the there are the tri-state gates. So this is the normal input, this is the control input, this is the output basically. So this is the construction of the tri-state gate for each bit of the each register, right? So when the input is 0, 0, so this 0 is high. When this 0 is high, so this control input is high, and the rest input in this case is 0, 0, 0. So all 3 tri-state gates react as a open circuit. Only this particular gate react as a closed circuit, because the control is high only this particular gate. Rest of the gate, the control is 0, so it reacts as an open circuit. So there is no current flow, that means no output is produced. In this case, this is high impedance, and if it is high, if it is high, A0 is high, so this receives A0 in this case when the inputs is 0 0. When the input is 0 1, so what we do? So this input, this B0 input is high in this case. This is 1 at this time, and this control is 0. So these three controls are 0. This means this Z. Suppose it is 0. So it receives B0 equals to 0 at this current time. Same designing we have to follow for the all of the decoders. So this is the basic working of the common bus system by using the decoder. I think it is very clear to all of you mind. Okay, so move on with the next slide. Okay, the next topic is general register organization or the general purpose register organization. So basically, the design of a CPU is a task that involves choosing the hardware for implementing the machine instructions. Let's describe how the registers communicate with ALU through buses. This is very important topic of the computer organization, how the general purpose register organization works. Basically, there are the number of registers. So there are the 7 registers in this particular organization. There is a decoder. I explained what is the working of the decoder in this particular register organizations. There are mux. This is mux A, this is mux B, and this is the input. So basically, how many inputs come for mux A or mux B? So there are the 8 inputs received by the mux A and 8 input received by the mux B. So first you have to know about the common bus system by using the multiplexer for find out how the size of mux in this particular diagram, how many mux we have to use for designing this particular diagram. So if I say that we have 8 registers, right? How many registers we have? We have 8 registers, and each register contains 8 bits. For example, each register contains 8 bits. So by the common bus system, how many mux are there? There are 8 mux, because mux depends number of mux depends on the number of bits. So if there are 8 bit, so there are 8 mux are used. Okay. Now, what is the size of mux? Size of mux totally depends on the number of registers. So there are 8 registers, so the size of mux is 8:1. Just a minute. It is 8:1. So basically, there are not only the single mux A, single mux. There are basically 8 mux in this place and 8 mux in this place, because we takes 2 buses. One bus A, second bus is bus B. So when we want that we do the operation, that is A plus B, right? Suppose we define that R1 transfers to R2 plus R3. So how this organization works in this case? So there are 2 registers R2 and R3. So this is highlighted. This is the input register R2. This is the input register R3. Each register has how many bits? There are 8 bits. So when we want or when we select the register R2, so how many bits are received by the mux? There are 8 bits are received by the mux A, because there is only not a single mux, there is a 8 muxes, because we receive basically the 8 bits of the register R2. Okay, so basically what the construction will do, just a minute, I explain like this. So if we take the register R2 has 8 bits, so it is basically the 8 mux. Suppose this is mux 0 for only the register R2 for the bus A, right? So this is mux 0, this is mux 7. Okay, this is M0, this is M7, this is M7. So each I0 to I7, because the size of mux is 8:1 in this case. I0 to I7 because the size of mux is 8:1, 0 to 7. So when the input is 0 0, when the input is 0 0, so which mux is which input is selected? I2, but in this case the resistor is R2, so we have to consider that this is I2 basically. So each mux input I2 is high because this is basically 0 1, 1 0. 1 0 means this is the decimal of 2. So binary 1 0, this means I2 is selected from the each muxes. So there is a configuration for the bus A is selected by the resistor R2, same as the construction of R3. So this is by the bus B. So if there are two inputs are there, so we use only two buses, bus A and bus B. If we have the another third input, so we used the bus C in this case, A, B, C. So there are 8 muxes in this configuration. This is the general purpose resistor organization configuration. And which register we have to select it for collecting the output value? So that have selected by the decoder. Because there are 8 registers, 7 R1 to R7 7 register, and one is the input register. So 3:8 decoder is used in this case. The decoder size is 3:8 because of 3:8. Why it is 3:8? Because there are 8 number of registers, there are 7 number of registers, and it is basically n 2 to the n equals to 7. So what is the value of n? So value of n is 3 in this case because there is no 2, because if it is 2 then it means 2 to the 2 equals to 4. So this is less than the 7. So we put the value of n is 3. If it is 3, so it is basically 8, and this is come in the output value, that is 7. So the size of decoder is depending on the n number of bits, and it is 3:8 size because the output, we know about the output, so outputs are 7. So the size of the decoder is 3:8 in this case. So this is the select D. I recognize or I define the input value of the decoder by the select D. This is the selection D basically. And because in the mux cases the size of mux is 8:1, so how many selection inputs are there? There are 3 selection inputs, because if the size of mux is 2q or n:1, so n is represented as a selection line. In this case it is 2q or 3:1. So how many selection lines are there? There are 3 selection lines for mux A and 3 selection lines for mux B. Now what it means? This is the ALU, this is the arithmetic logic unit. So arithmetic logic unit used for performing the operations, arithmetic and logical operations. And what is this? This is OPR. OPR means operation code. So how many operations performed by the ALU? Suppose we take the input, suppose the ALU perform 12 operations. So how many the bits in the OPR? So it depends on the, if ALU perform 12 operations, so if the value of OPR is 2, suppose this is the OPR bits. So if the OPR bit is 2, so how many operations performed by the ALU? So it is only 2 to the 2 equals to 4. So this is incorrect value. So increase the value of the OPR. So if the OPR have the 3 value, so ALU perform only the 8 operations. If the OPR value is 4, so ALU perform the 16 operations. So it is in the 16 operation, that is 12. So the correct OPR value in this case is 4. If we define the ALU operations are 16 or 12, if the ALU operations increases like 32, so the OPR bits are changed. It is from 4 to 5 because 2 to 5 equals to 32. So this is the basic working of the OPR. I think it is clear now. Now move to the next slide. This is the basic example. Okay, there are this is the example of the micro operation. So it is basically R2 and R3. R2 multiplied by R3 transfers to R1. In this case, we select the input registers, there are R2 and R3, and the output register select as a R1. Okay. And in the second example, we take the R1 and R2 is the inputs, and R1 is R1 as the output also. So there are this R1 is react as the input and R1 react as the output also. So this is the basic example of the micro operation. Now move on to the control word. Basically, this is very important. What is the control word? So control word have the 4 basic input values: select A, select B, select A by the mux A, select B by the mux B, select D by the input bits of the decoder, and OPR is bits of the by the ALU. If we take the operation, that is R2 multiply by R3 transfers to R1. So what is the control word in this case? So R2 means 2 is 0, 1, 0. We take the 3 inputs because the mux A bits, mux A selection bits are 3. So it is represented in the 2 represented in the binary 3 bits. So it is 0, 1, 0. So select A bits are 0, 1, 0. When it selects the register R3, so binary of 3 is 0, 1, 1. So basically it is 0, 1, 1. When the binary of R1, binary of 1 is 0, 0, 0, 1. So select D because it selects the output value by the decoder inputs. So it is 0, 0, 1. And we have to assume any operation. Let us assume the multiplication is defined as how many bits. Basically, it depends on the number of operations. So if there is no operations defined in this case, because there is a simple example of the control word, so we have to take the 5 bits for the OPR. So it is basically we have to consider that for the multiplication we have to assume that it is 0, 0, 0, 1. So this is the basic working of the control word. Let's take an example for the question on this particular topic, that a bus organization has 16 registers with 32 bit. Okay, we have 16 registers and each register has 32 bits, an ALU and a destination decoder, like as a GPR, a general purpose register organization. So we find out how many multiplexers are there in bus A. How many multiplexers? So multiplexer is dependent on the number of bits. So how many bits are used? There are 32 bits are used. So how many multiplexers are needed for bus A? That is 32, right? What is the size of each mux? Size of mux depend on the number of registers. So there are, how many registers are there? There are 16 registers. Size of mux is 16:1 in this case. Okay. How many selection inputs are needed for mux A and mux B? So selection input depend on the 2 to the power n. The size of mux is 16:1. So basically 2 to the power n is to 1. This is 16:1. So what is the value of n? So n is 2 to the power 4. Okay, this is n. The value of n is 4 in this case. So for the selection inputs, we required 4 as a selection input for mux A, 4 as a selection input for mux B. Okay. Now how many input and outputs are there in the ALU for data? So how many bits for mux A and mux B? From the mux A we have received the input values of 32 bits, and from the mux B we have received the value of 32 bits in the ALU. So let us explain that from the diagram. Okay. So this particular bits, just change the color. Okay. Receive the bits. How many bits? There are 32 bits received from mux A, 32 bits received from the mux B. So the input size for the ALU is 32 plus 32, that is 64. And how many bits are received from the output from the ALU? This is 64 or 32. When we add 2 bits, suppose we have the input values are 0, 0, 1 and second input value is 0, 0, 1, 0, 0. When we add these values, so the output values are received is 1 plus 0, 1, 0 plus 0, 0, 0 plus 1, 1. So how many bits are received? there are 3 bits are received. Same in this case, if we have 32 bits from bus A, 32 bits from bus B, so as the output value the ALU has received after the operation of R1 plus R2, so it is basically 32 or 33, because it also produces a carry bit. This is known as the valid bit. If the question demands that if it is a valid bit, so how many bits are produced by the ALU, so it is basically 32 plus 1, otherwise we have to consider in this case is 32. Okay, this is the answer. Now the last, design the control word that is R2 multiplied by R3 transfers to R1. So in the control word, we have select A, select B, select D and OPR. In this question, there is no defining the operations of the ALU, so we take the bits of OPR is 5 bits. Suppose the bits of OPR is, let us assume the bits of OPR is 5 bits, but how many bits are used in the selection A? Selection A, that is already defined for 4 bits. Select B, 4 bits. What is the select D bits? Because there are the 16 registers are there, so the size of the decoder is 4:16. So the select bits are 4 bits. Okay. So in this particular example, because the input values are R2 and R3, so the select bit is 0, 0, 0, 1. Select B bits are 0, 0, 1, 1, because it is R3, the binary of 3 is 1, 1. So it is basically in the 4 bits is 0, 0, 1, 1. And the select D bits are 0, 0, 1, because it is 1. So this is the output register, this is R1, and the let us assume the multiplication we use in 5 bits, it is 0, 0, 0, 1. So you have to assume any binary value for the multiplication operation. So this is the basic of the general purpose register organization, and this is very important topic of the computer organization. So thank you for this lecture.